our lab does diverse research on PFAS. So I've been involved in research, PFAS research for more than 12 years now. So we have covered detection of PFAS in various environmental matrices. We also develop technologies to capture them and also develop technologies to destroy them. So the reason we need to capture PFAS first before destroying them is like they occur in very low levels in the environment. So you can't really use a technology to go destroy them directly in the environment. It won't be energy efficient and it doesn't scale up easily. So you need to concentrate them to a level, then it's more makes sense to energy intensive technologies to destroy them.
I'm born and raised in New Jersey. I thought I've been exposed to every contaminant in the world here. PFAS, that's a new one for me. Tell us why it's a problem, and is it a problem?
Oh, it's a huge problem. And PFAS is not a new chemical. It's been used since the 1940s. Only now we've been discovering that PFAS is present pretty much everywhere in this world. It even occurs in the most remotest part of the world where there's no human activity, like the Arctic. They find PFAS in polar bears, which is crazy that how PFAS is like, migrating to all these remote regions in the world. It's a problem because it's not one or two chemicals. Like if it's just one or two chemicals, it's easy to target them and remove them. This is a family of chemicals. We're dealing about more than 15,000 different PFAS, and each PFAS behave differently in the environment. So you don't have one technology that can solve all the problem of PFAS. You need a combination of technologies, and first we need to understand how widespread this contamination is. The other part is the PFAS are tough chemicals. They are actually designed to withstand high heat, temperature, like resist water and grease. So they don't naturally degrade in the environment. So once released, it's going to stay there forever. That's why they get the name forever chemicals.
And walk us through why this is such an issue in New Jersey in particular.
So New Jersey, unfortunately, has a lot of Superfund sites, like heavily contaminated sites, and PFAS are used in many of these sites as well. So they are concentrated in many regions, and they have distributed and contaminated water sources in New Jersey as well. Another important is PFAS also occurs in biosolids. It's a solid byproduct of wastewater treatment plant, and it's typically used as a land fertilizer. And PFAS gets concentrated in biosolids, and when you reapply on land, they get back into the environment. And there are many sites in New Jersey that has applied the sludge on land that has contaminated the groundwater sources as well.
So what's the biggest challenge here? Is it detecting PFAS in a sample? Is it isolating it? Is it destroying it? Is it purifying it? Where are we in this whole process?
Yeah, so if you ask that question to different people, you're going to get a different answer. So you're going to be biased with what you think. So it all boils down, again, it's a family of chemicals that behave very different. So there's no one technology to solve this issue. So, but if you ask me the question, I think detection is definitely a problem because we want to detect PFAS at nanograms per liter. That's like one drop in a very large lake. So you really need very sensitive and precise technology to detect them. And the second challenge is to also destroy them because they are designed to be very tough. So there are no more energy efficient technologies that can destroy them efficiently. And even if you destroy them, you have to make sure that you completely mineralize them into substances that are not toxic. Because just because PFAS is disappearing, it doesn't mean that it's like completely destroying. You need to keep track of that it's like mineralized into fluoride and carbon dioxide.
Okay, so for the PFASolve into all of this,
Sure.
What is the role of PFASolve as it relates to these forever chemicals?
Sure. So PFASolve, we have a tagline from trace to erase. So we are developing technology for detection, capturing, and destruction. And we are focused on more practical and scalable technology as well, so that can save cost and time in both capture, destruction, and detection.
What are we doing as a society, if anything, to deal with what I would just call contaminated water? You guys probably have PFAS and other terms for it, but what most lay people would say, oh, that's contaminated, that's a Superfund site, that's contaminated water, don't drink it.
Sure.
Where are we now in terms of trying to deal with this on I guess, a more deeper way?
So I think US EPA has a regulation for like drinking water supply. So they are like doing nationwide survey to understand what are new chemicals that's popping up in our drinking water supply and whether these levels are in concerning levels. And if they are concerning level, they come up with regulations so that all municipal water treatment facilities need to maintain that regulation for safe drinking water access. So I think it's just by looking at the water, it might look clean. We can't really say that it's contaminated or not, but we rely on these research and guidance from the US EPA for us to move forward in that direction.
How did you get started in this field? How did you get interested in forever chemicals?
Sure. It all started with my PhD degree, where I did my research to identify new chemicals that we are in the environment. So my role was to develop new methods to detect contaminants, whether they're present in environment or not. And that's how I got into the field. And that time, we didn't have any standard methods for PFAS, so we had to develop our own detection methods. And when we saw it, it was pretty much everywhere. And that's how I got into this field.
And so what are the next steps, do you think? Maybe 30 seconds left here. What are next steps for you and your group?
So we have narrowed down on two technologies that we are currently focusing on PFASolve. One is the capture technology and one is the detection technology. And right now we are doing R&D and we are scaling up these technologies and we are doing validation and demonstration in the field so that it's commercially available for all.